Good morning, ladies and gentlemen. Isang makakaligasang umaga po sa ating lahat. Before we start, I'm gonna use the poll to so please share to us where are you joining from. You just wanted to see in terms of distribution. So 72%, 75%. So most of the participants today are coming from Luzon, 56%, and then 14% from Metro Manila, and then the rest from Visayas, Mindanao. And there are 5 attendees outside of the Philippines. Okay. So welcome to our second session for this webinar series brought to you by DENR-EMB and Clarity. So today, we're going to speak on how to design an air quality sensor network. So over the past years, advancements in technology have made the collection of reliable air quality data more affordable and more accessible. So new tools like air quality sensors can now be used to supplement existing regulatory monitoring networks, thereby increasing the temporal and spatial resolution of air quality data. So this session will be delivered to us by our application scientist, Maggie Aishid, from California. Good evening, Maggie.
Good evening and good morning, everyone. Yeah. Thank you so much for attending. So as Ethel mentioned, my name is Maggie and I'm based out of Southern California. My background is primarily in environmental sciences and public health, specifically focusing on air quality and its impacts on human health. I'm also a doctoral candidate at UCLA, finishing up my last year, again, studying air quality. And I am a former South Coast Air Quality Management District employee. So I worked in a regional air quality regulatory agency for 3 years, primarily doing community policy and monitoring, as well as a little bit of land use and policy work. So I'm really excited to talk to all of you today. Today, we're going to go over a little bit about the regulatory structure in the Philippines. We're going to talk about sensor network design, some air sensor projects that are implementing both regulatory and low-cost sensor technology, and we'll have about 10 or 15 minutes at the end for questions and answers. So as Ethel introduced, today's topic is really going to address how we approach designing an air sensor network. The challenges of air quality require new solutions and technologies, as our current air monitoring networks and solutions don't provide localized, real-time, spatial coverage of air quality and the potential issues. So a little bit of background on the Philippines Clean Air Act of 1999. This act requires implementation of the rules and regulations through air quality management and control. The Environmental Management Bureau, or the EMB, is the National Environmental Regulatory Authority, whose role is to implement national environmental laws. As a line of Bureau of the Department of Environment and Natural Resources, EMB has an independent enforcement authority. So underneath the EMB, the Philippines has 22 airsheds nationwide, which you can see on the map on the left-hand side of the screen. The local airsheds are headed by their own governing boards and are responsible for air quality management and control through the formulation of common clean air action plans, designations of attainment and non-attainment areas, and implementation of programs to improve compliance with air quality guidance values. So on this screen, you'll see a diagram of the air quality regulatory structure in the United States, starting from the national level, the United States Environmental Protection Agency, all the way down to the regional levels in California, using the California Air District regulatory structure as an example. In the United States, the US EPA is responsible for adopting health-based standards, air quality standards, and regulating pollution sources that can move across state lines, such as trucks, rail, and aircraft. The US EPA delegates the monitoring and environmental permitting to states and local municipalities. In California in particular, we also have a statewide air resources board who adopts its own statewide health guidelines and regulates mobile sources that move in and around California, so cars and trucks, buses, and other transportation. California is one of the only states in the United States to have a specific agency dedicated to air quality management and regulation. So in addition to that, underneath the state, California has 35 air pollution control or air quality management districts, which are regional agencies responsible for monitoring air quality, preparing clean air plans, and air quality management of stationary sources, or essentially sources that wouldn't move outside of that region. This regulatory structure is very similar to the way it is in the Philippines, which follows the relationship where the EMB would be equivalent to the US EPA and the California Air Resources Board, and the airsheds would be equivalent to the local air district or regional air districts in California. So diving in a little bit to low-cost sensors and how the US EPA views and recommends their use. So the EPA has begun to identify the use of low-cost sensors for various projects and has funded community, local, and regional municipality projects using low-cost sensors. The EPA has also used low-cost sensors for science education, academic research, and the measurement of localized air quality to better understand sources of pollution. US EPA also has invested in conducting technology development to collect and establish best practices to use low-cost sensor data. In 2020, the US Government Accountability Office prepared a report to better explore opportunities to sustain better air quality monitoring practices within the United States. And the study actually found that low-cost sensors have the potential to help meet some monitoring gaps and information needs that require hyper-localized real-time pollution measurements in addition to additional locations spread over the entire United States. In addition to the US EPA, there are other government agencies that are using low-cost sensors around the United States. So for example, in California, the California Air Resources Board has funded community air monitoring projects through Assembly Bill 617, or the Community Air Protection Program. This program states that communities that are disproportionately burdened by air quality and environmental issues will guide the development of community air monitoring planning. The community air monitoring plans may include technologies and have been encouraged to include technologies such as low-cost sensors. Another agency in California, the South Coast Air Quality Management District, has also been issued a grant from the US EPA to create the Air Quality Sensor Performance Evaluation Center, which studies and characterizes different low-cost sensors and evaluates their performance in different settings. And finally, in the Houston, Texas area, low-cost sensors have been used by the city of Houston, the county in which Houston is in, and community-based organizations. This data is currently being used to influence city activity, such as mobile monitoring when residents have air quality complaints. And additionally, a US EPA regulatory grade monitor has been installed in the community as a result of low-cost sensor monitoring that wouldn't have been available otherwise. So when considering where to place sensors, it is important to identify what your major sources of pollution are. And in the Philippines, major sources of pollution include agricultural burning, wooden cook stoves, cement batch plants, coal-fired power plants, and mobile sources, specifically traffic. And the diagram that you see on the screen just demonstrates some of the sources of that pollution and how it would fit into the sources of pollution and the emissions. So one big question when looking at low-cost sensor technology is how to design a low-cost sensor network. Asking questions such as, where should the sensors be placed? how many should be purchased, what sources do you want to measure, what pollutants are you interested in, and what rationale goes behind where the sensor should be placed. There is limited literature on sensor network design since this is a newer technology. However, based on all the information that is available, the methods that people use to determine where to place the sensors can be categorized into two methods. There are quantitative methods and qualitative methods, which we'll go over each of these generally in the next slides. And this image is a map of Jakarta representing the existing reference grade monitor and additional monitoring locations with clarity nodes. So when citing low-cost sensors, there are a number of factors to consider that should align with the goals of the project that you are working on. 4 of these major factors that are listed on the screen include: 1, what is your research question or project goals? 2, what is your budget and number of sensors that you can purchase? 3, do you have access for where you want to locate these sensors? Do you have an idea of where you'd like to locate them? Are you looking to evaluate air quality at specific locations, like where people spend their time, such as schools? And finally, what pollutants of interest are you looking to measure? And I'll go through each of these in the upcoming slides. So the first one are, what are your research questions and goals? So ultimately, what questions are you trying to answer? For regulatory purposes, for example, a lot of agencies will use these low-cost sensors to identify hotspots or to help identify sources that are within the community. Is your goal to inform air quality policy information? Is your goal to look at exposure assessment or answer some health-based questions? Is it to better understand sources? Is it to assist in citing a reference grade monitor, as in the example of the city of Houston, Texas? And finally, who are you planning to disseminate the data and measurements to? Is it meant to be internal, or is it meant to be presented to the public? The second question is, what is your budget and number of sensors? So it's important to identify your resources and limitations so that you can prioritize where you'd like to place the sensors. The beauty of low-cost sensors is that after you've collected data for a certain amount of time, you can move them around. Where are there data gaps that you'd like to better understand? Have certain communities or regions identified areas that need additional monitoring? And finally, prioritizing areas that have limited monitoring or are densely populated, as is aligned with your project goals, are all important. Okay. The third factor that's important is the location of sources and sensitive receptors. So one great method to use is organizing a map of locations that you'd like to monitor. You could diversify your locations if you have multiple project goals. So placing some sensors in residential areas, industrial areas, commercial areas, traffic locations, or recreational spots where people spend their time. Some factors to consider that could influence your the measurements are the geography. So is it generally flat where you are? Is it hilly? Does the elevation change? What is the weather? What is the temperature and relative humidity? That will also impact where you place the sensors or what data is being collected. Are there sources in that area? What is the wind pattern in that area? You could place, for example, you could place a monitor near a source, but if it's not in the direction of the prevailing winds, you won't pick up anything. So it's important to factor those in when considering where you're going to place them. And finally, what sources are you interested in better understanding? So is it mobile sources? Is it stationary sources? Is it area sources? And what are the pollutants associated with those sources? A lot of low-cost sensor technologies are really good at measuring PM2.5. For clarity, we also have NO2 and ozone as well. So it's important to understand what pollutants you'd like to measure. So in terms of quantitative methods, these are kind of computational methods that people have used in the literature to perform sensor network design and to understand where the best placement would be. So one method is the multi-resolution dynamic mode decomposition model, which is a method that I will discuss further in the next slide. But the image on the top right that you can see, essentially this method uses variation in the concentration of air pollution over time to identify where would benefit the most from sensor network or from sensor placement. And for this data, you would need spatial data and you would need historic air pollution data. Another method is the Gaussian process model. And this model, your computer is trained to identify good placement of low-cost sensors across space and time and provides the most informative location about uncensored locations and evaluates the effectiveness of sensor placement once the sensors are placed there. And you can see that image on the bottom left. Essentially, it's a map of where the inputs to the model are spatial, and then the model spits out ideal locations for sensors. So going off of the multi-resolution dynamic model that I discussed in the previous slide, this was actually a US EPA funded study where researchers used a quantitative model called a multi-resolution dynamic mode decomposition model to identify the placement of additional PM 2.5 monitors. The research used PM 2.5 data obtained between 2000 and 2016 to study the variation of PM 2.5 concentrations daily to identify high priority sensor locations. The image on the right shows two maps. The top map shows 2016 US EPA regulatory monitoring locations and coverage. And the map on the bottom shows additional areas where the study showed could benefit from additional PM 2.5 sensor monitoring. So essentially, the study is suggesting an additional 1,369 locations that would need to be supplemented as a result in the gaps in the US EPA monitoring. So once you have set up your low-cost sensor network, once you begin collecting data, there are different ways that you can interact with the data. So for example, with Clarity provides an API, which is an interface that customers can use to acquire data from Clarity system to build their own tools or integrate their data with third-party platforms. One benefit of using low-cost sensors like Clarity is access to data via an API or a dashboard. The image, for example, at the top left is the City of London, which we'll talk about in a couple of minutes. They developed this map for their Breathe Air London program. The image on the top right is an example of a hyper-localized air quality map developed by Ramble called Share. Clarity data, in addition to other air quality and land use data, is ingested from the API and fed into this hyper-localized model. Additionally, Clarity gives you an internal dashboard that you can analyze, measure, and monitor your network's health. The image on the bottom left is an example of the internal Clarity dashboard. The image on the bottom right is Clarity's open map, which you can opt into to inform the public to access PM 2.5 measurements from the dashboard. So just a little bit of a clearer picture of Clarity's dashboard and Clarity's open map. So the dashboard on the right-hand side is where you can manage your nodes and you can do data analysis. And then the map on the bottom left is the Clarity open map, which is really useful for citizens to be able to monitor their air quality. What's beautiful about the open map is it's an opt-in system, but aside from that, the Clarity dashboard is internal and can be managed by staff at the regulatory agencies internally. So here's an example of a hybrid network in action. So the Breathe London network launched in January of 2021. Following a successful 2-year pilot, the Mayor of London took over the funding of the network, appointing the Imperial College of London to manage the program. This network integrates air quality measurements from hundreds of air sensors with the reference grade measurements by providing London's regulatory air monitoring network, which is the largest and most advanced in Europe. This project demonstrates that although there is a sophisticated network in the City of London, there is also high demand for localized air quality monitoring. In addition, Breathe London also had a strategic public-private partnerships, which allows citizens to engage in the issue of air quality as never before. And there are organizations that are either looking to deploy nodes or would like to donate nodes to communities, which again demonstrates that public-private partnership with this program. So this is another example. The map on the left-hand side is just regulatory monitoring in London. So even with a comprehensive network like there is in London, there are still gaps in the monitoring. This network has now grown to over 400 sensors to address local concerns, as you can see in the map on the right. These two maps represent the difference in air quality monitoring coverage before and after the launch of the Breathe London program. And the map on the right shows the drastic increase in air quality monitoring coverage that would not have been feasible in a reasonable amount of time without the low-cost sensor technology. Another example is Quezon City. So in 2020, Quezon City local government partnered with C40 and Clean Air Asia to develop an air quality baseline pilot study to support Mayor Joy Belmonte's Clean Air City's declaration commitments. The baseline results provide insights that can be used to identify opportunities for clean air intervention. These interventions can then be used in the city's air quality management plan to help Quezon City meet the World Health Organization's air quality guidelines. So in addition to that, Clarity has also prepared a guide to planning and managing a low-cost sensor network, which will be provided to you after this webinar. So kind of just summarizing everything I discussed today, it's important to know what your monitoring objectives are, what are your regulatory or non-regulatory grade performance metrics, what spatial and temporal resolution will be necessary to achieve your goals, and what pollutants are you looking to monitor to reach those goals. And you can learn more about that in our guide to leveraging low-cost sensors for air quality monitoring. And this is something that Clarity staff and project managers can also help walk you through as well. So before I finish my presentation, I would like to invite you all to register for the next webinar on December 6th, which is about how cities are using sensors to supplement regulatory monitoring, which will be led by Sean. And thank you so much for all of your time, and I'm happy to answer any questions.
Thank you, Maggie. For questions, you may type all your questions to the Q&A chat box, or anonymous are also allowed, so you can just type in your questions, or you can also raise your hand and then we'll try to call you. There's a question here from an anonymous attendee. So how can we measure the wind direction? And also maybe to add to that, how can we determine the number of points to measure the wind direction or wind speed in an ambient network?
That's a good question. So I'll give you a very overview answer as a non-meteorologist, but one way to measure wind direction, so Clarity does also have a wind module that can be installed on our nodes. And essentially what the way to measure wind is through something called a wind rose. And the wind rose will show you what direction the majority of winds are coming from. So that would be one way through our node. Another way is most regulatory monitoring sites will also have a meteorology component or a wind component to be able to measure the prevailing winds or the direction that the winds are primarily coming from. And then Ethel, to answer your question, it really, a very simple answer, and it's not so simple all the time, but a very simple answer to that is looking at kind of the geography of the area. So is it very flat? Is it next to the ocean, which all of the Philippines is? Is there mountains? Is there terrain changes? This can all impact wind direction. And one good visual of that is Southern California. So because we're kind of all embedded in these very large mountainous valleys, the wind direction just does change regularly. So if you are near the ocean, you'll probably have change in wind pattern. And I would say the more of those factors you introduce into your network, the more wind monitoring will be necessary.
Yeah, because I think some are just considering downwind and upwind when placing wind monitors or wind modules in their sensor network design or in their maybe in their reference monitoring network.
Mhm.
So another question is, does low cost sensor means also low quality PM measurement?
That's a good question. And there has been a lot of kind of controversy around this technology, but if you are interested in some like, I guess, third-party evaluations, the AQ spec, which is the program that US EPA funded at South Coast AQMD, does an evaluation of low-cost sensors, and they've found that Clarity and other sensors have been almost identical to regular reference grade monitoring in terms of performance. So for example, Clarity performs at when compared to a regulatory grade monitor at anywhere from 0.8 of an R-squared value to 0.96, which is highly statistically significant. With other pollutants, there are calibrations and adjustments that can be made to the data to account for some of that variability, but it doesn't necessarily mean low quality. And at Clarity, at least, we very much invest in calibrating and ensuring that the sensors are co-located with a reference grade monitor first to ensure their performance. And we have them deployed around the United States as well at other regulatory sites to measure their performance over time.
Yeah, and to add, maybe also it's a problem with the terminology using the low cost sensor, because it's a misconception because it's not actually low cost. It's lower cost as compared with the reference, but operating and maintaining a sensor-based technology would actually be costly sometimes in the end, because you need to replace all the sensors because they have also life.
Mm-hmm.
And then another is, can the sensors be activated through solar energy?
Yes, they can. And so our Clarity nodes are operated by solar energy. So you do not need a power source to operate them.
Yeah, and it's because also most of the sensor-based technology, this is being used in areas where there are difficulty in terms of finding a direct power source. So we really need other options in terms of powering up the nodes. What is more important, road measurements or in neighborhoods? Maybe this is about the pollutants that needs to be monitored for roadside installations.
Yeah. And I think it goes back to what the ultimate goal of your hybrid network is. Is it to understand the impacts nearby the road? Are there residents near the road? Or is it to understand maybe the exposure to the residents or what they're actually breathing at their location? So I think it just depends. You could install one in each place, which some projects do, to understand what, like, if you're, for example, if your home is like 1,000 meters from the road versus, maybe 50 meters near the road, what the difference in the pollutants would be. But yes, to Ethel's point, it would also depend what you're trying to monitor. So if you're looking at roadway exposure, or I'm sorry, roadway measurements versus, I don't know, ozone, might get different. You might design your network differently.
Yeah. But will they be focusing more on particulates or PM10, PM2.5, or also including some gaseous pollutants?
Mm-hmm. Yeah.
How often do they need maintenance? This is for low-cost sensors.
That's a good question. So I know for us at Clarity, usually the lifespan has been average around 2 years, but for us at Clarity, we have nodes that have continued to work in the field for the last 5 years. So it really depends, but usually the time span is on average in the low cost sensor space is like 2 years.
Yeah, and most of the low-cost sensors, they often don't need any physical maintenance. Most of them, including Clarity, are being monitored remotely through the software or the dashboard.
Yes.
Will the place Are you saying something?
Oh, no, I just said that makes more sense as an answer. Yes.
Yeah. Will the placements of the sensors affect the results?
Yes. So depending on where you place them and in what direction, it can absolutely affect the results. So, for example, if you have a facility and so if the facility is here and the wind is coming from up here and you put the sensor up here, you're not going to capture what's happening at that facility. So you'd want to put the sensor like down here. So it does matter where you place it to get optimal results. Again, depending on what your goal is.
Yeah, I think this can also be answered by the qualitative methods or the factors that you've discussed about the source receptor and also the project goals and objectives. Because it will definitely be different if they haven't considered the sources and then the receptors and also other factors such as geography, meteorology, topography of the area.
Absolutely.
And let me see if they have more. Okay. What do you mean by co-location?
That's a great question. So we define co-location as placing a low-cost sensor or for example, with Clarity, a Clarity node at or very close to a reference monitor or a regulatory monitoring station. And we recommend placing it there. And actually the US EPA recommends placing it there to collect data for at least 30 days to monitor its performance as compared to the reference or the regulatory grade monitor. So for some cities and counties, we have continued to keep that monitor or that low-cost sensor at that reference monitor to better understand its performance over time. But if I, for example, am a community-based organization and I want to deploy it in my community, I would place my low-cost sensor at the reference monitor for 30 days. We would, or someone would calibrate that data or do some assessment to ensure that the quality is good. And then those sensors can be moved to, ultimately where you want them to be. Or if you wanted to continue to measure the performance of that low-cost sensor, you could keep it at that reference site for a longer period of time.
Yeah, and I guess US EPA has released a performance assessment document to guide government agencies and other institutions in terms of how to do the co-location. So I guess they can, we could probably share it to them through email, the link for that document, and they could refer to that so that they would also know what are the criteria that they need to evaluate in terms of co-location and assessing the performance of different sensor-based technologies available in the market as compared with a reference instruments. So basically, what Maggie is also saying is that co-location is providing traceability to the sensor as compared with a reference standard that is being used in your area or in your country or in your organization. So another question is, are all these sensors repairable or they are disposable?
That is a good question. I can say for clarity, it depends on what the issue is. If it's, damaged by accident or if it's just, a component that breaks down, we're very good about replacing it to ensure that you continue to monitor the quality. I can't speak to other low-cost sensors though, and whether they're repairable or not. I would imagine more of them are disposable than repairable, but I'm not 100% sure.
Yeah, maybe to address this one also, just for them to have an idea, most of the low-cost sensors technology available right now for particulate matter, they are using optical particle counter, and then for gaseous pollutants, they are using electrochemical cells. This kind of modules or sensors, they have also life, like 2 years, maybe some are one year, 1.5 years. So if you are gonna replace this one, might as well buy a new sensor. So because the cost will actually be the same. But for clarity, we are different in such a way that we are not selling the hardware. So we're not selling the sensors, but we are providing the service, meaning we are providing the hardware and then the software and then all the services. And then you just have to pay us for a certain fee annually. And then throughout that annual period, whenever there's a problem with the sensors, then we're going to replace that sensor with a new one. So you're not investing with the hardware because eventually that hardware will need to be replaced, especially for low-cost sensors. Oh, there are other questions. How many sensors are needed in a city like Manila? So maybe the coverage. I mean, how many sensor per square kilometer?
Mhm. That's a good question, and unfortunately does not have a simple answer. I think it, kind of as I described, it depends on your budget, again, what you're trying to do with them. Are you trying to supplement like regulatory monitoring? Are you trying to identify a specific source? Are you looking at exposure? And so it would be very difficult to give a number. It really depends on all of the factors that we described earlier.
Yeah, especially for the budget, because some cities, if they have the budget, I think they are deploying one sensor per 5 square kilometer, and that would be a very dense network in terms of deployment. For a big city, if they have this kind of funding, then they could at least deploy one sensor per 5 square kilometer. But they could do, I think, phase by phase implementation, setting up the priorities. What are the hotspots? What areas do they need to first monitor? And then from there, I think they could just expand the network or maybe relocate the first deployed sensors to other areas that needs to be monitored more.
Yeah, very similarly to the Breathe London network. We started, I think, with 120 or 200, and now it's over 400. So it's definitely been like a phased deployment, and the needs have kind of been built upon and changed as they've continued to grow their network.
Yeah. So are the low-cost sensors fully implemented now in the US?
I guess
there are a lot of states or counties using it.
There are, yes, there are a lot of states, a lot of community organizations, a lot of regional and cities and counties that are using low-cost sensors. For example, as I mentioned, in Houston, Texas, they're being used to re-site a reference grade monitoring or regulatory grade monitoring. They're being used for community-based monitoring in California in disadvantaged communities. So I would say they're fully implemented in the US.
And also with the support of the funding coming from the federal government, right? Because they are giving funds for community based monitoring or environmental justice application.
Yeah, absolutely. So federal and state funding is critical. And some states and some areas in the United States are eligible for some COVID relief, and they've used that funding for air quality monitoring. So yeah, different funding streams, absolutely.
Okay. Do we need different sensors to measure different pollutants in the same area?
I think we might have skipped one question. I don't know how to answer it though.
Oh, okay. There's one. Due to financial constraint due to LGUs, would it be possible that DNR can provide the sensors? I think DNR can answer this, or you can, for all the local governments, I think you can coordinate with your regional environmental management bureau offices and ask them. But if you are interested to initially deploy, maybe try out our system, you can contact us and then we could initially check what partnerships or how can we help you in terms of deploying this kind of sensors. If we could help you find funding partners like what Quezon City is doing right now.
Mhm.
Okay, and then do we need different sensors to measure different pollutants in the same area?
It's a good question. So for clarity, for example, we measure our nodes measure PM 2.5 and NO2. There is an optional soon to be released ozone module and a wind module, but these can all be essentially it's a module built on top of the node, so you don't need additional sensors, if you will. But for others, you might need more than one sensor to monitor in the same location, but not for clarity. We can do those three in one location.
Yeah, so it actually depends on the brand or the sensors available. But because for each pollutant, you need a different module or sensor component to monitor that kind of pollutant. So even if for clarity, we are just deploying one node to measure NO2 and PM 2.5, but then the sensor that is monitoring that kind of parameter is different. Do you have any project in collaboration with the government in the Philippines? I guess I can help you answer this one. In the Philippines, Clarity is being used by Quezon City government. So this is in partnership with C40, an organization that is initially funded the project, but then for the continuity and expansion of the project. So from 8, I think Maggie flashed that slide earlier when they started with 8, courtesy of C40. And then they've expanded. Well, right now they have 20 sensors. So the expansion is coming from the funds from the local government. So there. So they started June of 2021 with just 8 sensors. And now, 2022, they have 20 sensors deployed around Quezon City. There's also a small network being operated by Clean Air Asia in the city of Manila. So I think there are 3 or 4 sensors currently working for the city of Manila right now. Okay, any more questions? Though that was a lot. And thank you, Maggie, for answering all these questions.
Thank you. Thank you all for attending.
Yeah, I have one more. In terms of the factors for the qualitative method, which do you think they would prioritize among those 4? Because I flashed a poll earlier, and the answer is almost 40%. They would prioritize the budget, and then for another 40% is for the project goals.
That's a good question. I would say between the two, I think really understanding what your project goal is, or in the case of any government, like what you're trying to achieve with the data is going to drive the rest. Because if you don't know what your question is, then even with a budget, you could deploy too little or too many that won't achieve the answer that you're looking for or won't help you answer that question. So I definitely think like understanding ultimately like what is it you're trying to do with the data and with the sensors and what you're trying to collect is probably the most important.
Yeah, I think I also agree with that. That it is project goals first before the budget. Though, yeah, budget will be a limitation, but instead of like deploying 5 or 10 sensors that possibly will not address your problem, it's basically will be useless in the end. So it will be more significant if you start with the project goals, and then from there you determine in terms of the number of sensors, if the budget will fit in with this number of sensors, or if you just choose to implement it phase by phase, at least it would be answering your project goals or objectives.
Exactly.
Yeah. So if you have any other questions, you may contact us through email And then we'll also be sending you the link for the feedback. So please answer that one, and then that would actually help us in terms of improving our next sessions. Also, the recording will be sent to you through email. You can access that anytime, including the first session. So thank you again, Maggie, for this webinar.
Thank you so much, Ethel, and I hope everyone has a good rest of your day. Take care.
Yeah, thank you.